All right, so just a quick reminder to what we've done last video. We looked at the greatest common factor, how to do so. Then we took a look at our binomials, so differences of squares and examples that cannot be factored. So today we are going to be looking at our trinomial. So what types of examples do we have with those? We have our perfect trinomial square. We have our regular trinomial, and we have our trinomials that cannot be factored. Okay, so let's take a look at our first example, which consists of our perfect trinomial square. All right, so here we have an example of our perfect trinomial square. So we're given 9x squared minus 24x plus 16. So how can we identify that this is a perfect square trinomial? Well, first, let's see, can we factor anything out? In this case, we cannot, so we don't have to worry about that. Okay, now we're going to determine how it is a perfect trinomial square. What you want to look at is you want to look at your first term and your last term. So let's first take a look at our first term here, 9x squared. Let's square it out. So 9x squared, square rooted. You get 3x. Okay, awesome. Let's leave that there. Let's look at our third term now, which is the 16. Let's square root that. Square root of 16, you get a value of 4. Now, you want to look at how is it in relation to the middle term. So, if you can multiply the two together, so multiply 3x by 4, and then multiply by 2, and you get your middle term, then you know you're dealing with a perfect square trinomial. So let's take a look at that. So we have 3x, essentially, times 4. You get 12x. Now we know we got to multiply by 2, so we're going to multiply by 2. You get 24x, which is, in fact, your middle term. So you know that we're dealing with a perfect square trinomial or perfect trinomial square. Now you are going to be using the 3x and the 4 when we involve it in our equation, okay? So let me erase this out. Let me erase this so we can write it out. All right, so let's get back to our red marker. So in both of our brackets, we're essentially going to have, similar to differences of square, you have your 3x here, your 4, your 3x here, and your 4. Now understand that whatever sign is in between these two terms is going to be the sign before that middle term. So in this case, you're going to have minus and minus. And that's how you do it. That's how you do your perfect square trinomial. Let's say it was a plus here. So if it was a plus here, then you were going to make these two pluses, but it's not. So let's just undo those. Awesome. Now let's verify. So let me draw this out in a different color. Us verifying 3x times 3x, you get 9x squared. 3x times negative 4, you get minus 12x. Negative 4 times 3x, you get, so negative 4 times 3x, you get minus 12x again. And then negative 4 times negative 4, you get plus 16. So overall, you do get your 9x squared minus 24x plus 16. And there you have it. That's your way of figuring out your perfect square trinomial. Alrighty, so our next example is going to be an example of a regular trinomial. So first, we want to see, is it a perfect square trinomial? So let's do that over here on the side. I'll do that in blue. So we have 2x squared. Let's take a look at that. Let's square root 2x squared. Oh, we already run into trouble, right? We can't square root 2 and get an integer. So we know that we're not dealing with a perfect square trinomial. This is essentially just a regular trinomial. So how do we deal with regular trinomials? Well, let us write stuff on the side over here. So what you want to do is you want to figure out what two numbers will multiply to give you this first value, 2, times the third value, the third term, negative 15. So what two numbers multiply to give you 2 times negative 15, which is negative 30? And then you essentially want to see what two numbers will also add to give you 7. So your middle term over here, I'll write that in a blue, light blue. So 7. Okay? So let's think about it. Well, if we multiply 10 by negative 3, we get negative 30. If we add 10 plus negative 3, so 10 minus 3, we get 7. So we know our two values that satisfy these two circumstances is 10 and negative 3. So what do we do from there? Essentially from there, we're going to be splitting up that 7x into those two things. So we're going to have 2x squared plus 10x minus 3x minus 15. And essentially what you're doing is you're going to be grouping. So this relates back to the concept of polynomials, which we'll look at in another video. But essentially, you're just going to factor out these two sections that I have created. So you're going to treat this whole thing separately to this whole thing. So if we take a look at what that does, let's write it out. We factor out 2x since that's the GCF of this, and you get x plus 5. Okay? Now let's deal with our second term over here, or the second section, this whole thing. What we have is, let's factor out 3. And then you get x plus 5, right? Because 5 times negative 3, you get 5 times negative 3, you get negative 15. Negative 3 times x, you get negative 3x. So this works out. Now that you've done this, you have a factor between the two. What's the factor? Well, if you look at it, it's going to be this over here, your x plus 5. So we could essentially just turn that into one term. So let's do that. We get x plus 5. All right, and what do you multiply by? Well, what you're going to do is you're actually going to take these and you're going to create one term with that. So you get 2x minus 3, right? Because that's that, and that's that. Okay, and you're left with this, and then you can verify by expanding. I want you to try that out on your own, but that is essentially that. All right, so remember, with any polynomial, you're going to make sure you're checking for a greatest common factor first. And with trinomials, I'm not going to show an example that can't be factored because you can figure it out yourself. If there's no greatest common factor, it's not a perfect square trinomial, and it's not a regular trinomial, then it cannot be factored, okay? And then we have our last section, which is your polynomials, which is grouping the terms into factorable, binomial, or trinomial groups, which was similar to what we did with regular trinomials. So yes, that's it. Thanks for watching.